Hey class, this is question 81 from chapter 9. We're asked to graph and shade the solution for the system of inequalities shown below. Um, my hope is that this video right here gets 0 views, meaning that I hope you know how to do this. Now, if you're here, don't feel bad because I've been there too. In fact, I'm often there. I'm often confused by things. But thanks for giving me a chance to try and explain this to you if you are confused a bit. So everything's set up actually, and if I swapped out those inequalities instead of having this greater than, if I just wrote equals to, right, for both of them, I could basically figure out what the boundary lines are for these. So one of them is 3/4 x minus 2 has a y-intercept at -2 and a slope of up 3 over 4. The other one is y is -1/2 x plus 3. So I can see that's has a negative slope. It's down 1 over 2 and a y-intercept at 3. The top one is going to be a solid boundary line because this is the strictly greater than symbol. The other one is going to be a dashed boundary line because this is the strictly less than symbol. So let's put those things together and see if we can't figure out where the solutions to this system is. Because remember, what we're looking for here is we're looking for all the ordered pairs that work for both. Um, yes, we are. So I'll use this kind of yellow color for this one, and we'll do that first. So this is the solid boundary one. So I've got a slope of 3/4 and a y-intercept that lives at -2. So here's the -2, and then I'm going to go from there up 3 on 2, 3 over 4. 1, 2, 3, 4. There's a boundary point, and I'll do one more up 1, 2, 3 over 1, 2, 3, 4. There's a boundary point. So from those points, I'm going to go ahead and just grab the ruler and connect them. So that is our first boundary line, and it's a solid boundary line, and this inequality says that my y values are things that are above that boundary line. So these values that are above this, these are all solutions to this inequality. So I'm just going to putting a few of these here just to kind of remind me that it's above that boundary. The next boundary, I'll use this bluish color right here. And my boundary here is the line, but it's going to be a dashed line. Y is equal to -1/2 x plus 3. So I'm at +3. And from there, I'm going to go down 1 over 2. So down 1 over 2, down 1 over 2. Oh, those points meet right there, right? They both meet at that point right there, right? They both meet at 4, 1, I think. Down 1 over 2, down 1 over 2. So let me go ahead and grab my ruler and line it up. And I'll go ahead and put arrows on each end because this continues in both directions. So for this one, it was a dash boundary line, meaning the points on there are not solutions, and it's my y values are those things that are below this curve, right? So below this. So at a certain point, right, it gets to be the case that there's a region that's matched with both of these, right? It's making both conditions true. And if I was to kind of highlight that region, it is not including this dash line, right? But this dash line is the boundary for the solution. It is including this line here, right? Oops. And it's everything that's in between here. So all of these values, right, that live in boy, I'm getting this aggressive coloring job here today. All of these XY pairs that live in this region are solutions. And interestingly, although if I was going to solve this system of equations, if that was a system, I believe the solution is x is 4 and y is 1. Let's see, if I was to put 4 there, that would be 3 minus 2 is 1. Yeah. And if I put 4 there, that would be -2 plus 3 is 1. Yeah, so 4, 1, that point is a solution to the system, but that point is not a solution to the inequality, because although it is on the orange line, it's not on the blue line. It would have to be on both. That point would satisfy this inequality, right? it would make this one true, but it would not make this one true because that one doesn't contain the line. So anyways, that's the solution there. That's the one what I came up with. Anyways, that's question 81, and I'm really sad that I colored in that graph like that. It doesn't look very good.